Bismillah. We have basically most of what we have covered is something that you have already covered before, right? The vector. So this week, last week, we have covered in terms of the two-dimensional. So this is where we got into three-dimensional Cartesian vector, right? And then how to deal with vector in 3D. Of course, in 2D, we do not need to use Cartesian format, right? But we have done that before. Right? Anyway, so most of the real object in engineering application is 3D, right? So that's why we need to know how to deal with three-dimensional objects. Right? For example, things like this. Meaning is not only like what we have done in the previous class where everything is in the same plane, but still we have IJK, the real structure. Right. So one thing that you have to understand in terms of using the Cartesian vector notation is the right-hand rule. But we will not touch on this yet because this will comes in later when we do cross product. But the thing that is introduced is here about unit vector. Right? You have learned about unit vector before? Yes or no? So unit vector is a vector. Of course, I would like to remind that the way it is noted here, because it's bold and italic, meaning it's a vector, right? So the way we write in on paper is basically something like this. Right? The unit vector of A is vector A divided by the magnitude of A. Right? So as we have mentioned before, if you fail to note whether it's vector or scalar, then it will be a problem. Now the characteristic is that the magnitude is 1. Right? Meaning that if we put in another way, right? If we have this with a magnitude of, how to say, if this is a magnitude of A, meaning the magnitude of this vector is A, in vector notation it will be like this, right? Meaning it is something I plus something J plus something K in 3D, for example. So if you have a vector along this line with a magnitude of 1, this will mean vector A. So that is what it means. Meaning it's a vector because when you divide these vectors, you will get 1 in this direction. Right? So this is the meaning of. So the magnitude of a unit vector is always 1. It is dimensionless because if this in Newton, this will be Newton. This is meter, there will be meter. So when you divide, the unit cancel, it becomes dimensionless. And it points out the same direction of the original vector. Now, why we always deal with this? Because when we know something, if unit vector of something, and the magnitude is 1, so if you know that, okay, the vector now in this same direction is 3, so it's just 3 times the unit vector. Right? So that's why we always calculate for unit vector, so that when we get any value of magnitude, then we just multiply by the unit vector to get the actual vector. So if this is like 1i plus 1j plus 1k, then if the magnitude is 3, you just multiply, for example, right? That's one thing that will be something very common throughout our course, the unit vector. Right? Now, IJK itself is also a unit vector. Right? So if you have the 3D coordinate, x, y, z, or the axis. So when you have a vector here with a magnitude of 1, the vector will become I. We get magnitude 1 here, the vector is j, magnitude 1 here, the vector is k. Right? So that is why when you have, for example, 3 here, then will become 3i, etc. The same concept as this one, right? So yeah, so make sure you understand this one also, because sometimes when you need to find coordinate vector later on, there's a calculation involved, but sometimes it doesn't need calculation when you know. The question is, what is the unit vector along this line? Straight away is I. You should understand that already, right? Everyone follow so far? Okay. Now, as we have discussed in previous in 2D, right? In 2D we have two types of angle that we have discussed. One is the form of theta. One is the triangle, right? So similarly here in 3D, there are several ways that the angle or the direction can be presented, and you have to know how to deal with it. Okay, one is this one. Basically, if you have the axis x, y, z, and you have a vector basically like, so for example, where it maps out to, for example, okay. So this means that it will have the x component over here, y component over here, right? So z component over there, right? So if the vector is a, then normally this will be ax, y, and a z. So in terms of Cartesian vector notation, it will be a equal to ax I plus ay j plus z k, right? So you have seen this before, right? Meaning that if you know the component, the x component, y component, z component, you just can plug in to get the vector. So that's one understanding of that. So if you have to calculate, then sometimes you need to know how to deal with the triangle here and triangle there, right? How to use trigonometry here and then trigonometry here, right? So that's one aspect that you need to know. So the vector A can be defined as axi plus ayj plus azk, right? Okay. Here it is basically how to say, deriving an equation. So if we take a look at the triangle of, if you see here the blue triangle here, right? No, sorry, it will, here it's first. If you look at the gray triangle there, it will be something like this. If you look from top, it will be something like this. This will be this will be a y, this will be a x, right? And this is labeled as a prime. So quite simply, the relationship can be expressed as this, right? Ax squared plus ay squared, right? And then if you look at the blue triangle there, which if you look from the perpendicular to the plane, it will be something like this, right? Well, this is perpendicular. So this is a prime, this is a, this is az, right? So the relationship can be a equal to a prime square plus az square, right? But if this one is a prime square, it's basically simply ax square plus ay square, correct? Meaning that this one here is the same as this one, right? You can just replace, so hence you get square root of ax square plus ay square plus az square. Because meaning you just plug in this here, right? So basically you will end up with this equation at the bottom here. So this is just to show how this is established, right? Meaning that if you know the component ax, ay, az, or if you already express this one, I need to know, if I need to know the magnitude of A, what to do is just simply ax square plus ay square plus az square from here. So things like this, it can easily be derived as such, right? If you understand trigonometry here, you can straight away know how this is derived, right? For the purpose of exam, if you don't care about that one, you can just also memorize this. Right? That's also fine. Because normally, this one we tend to just straight away apply. Right? But it's good to know where it comes from for engineering purpose later on. Right? It is very useful. But as I mentioned, for those who just want to memorize, it's also okay in terms of the exam. Any questions so far? So that's how to get from the vector to the magnitude. Right? Because normally the question, just like in 2D, right? When we have in terms of xy component, then we want to find the magnitude and angle. So similarly in 3D. Okay, so that's the magnitude. Okay. That's one way of angle presentation, meaning that the question can have a vector somewhere there which you are given something like this. So you have to know, or from here I can find what is x, y, z component. The question can also give you in a different format where it just gives you this angle, and this angle, where this is alpha, beta, and gamma, right? So that's different representation. In this case, it might be not straightforward to get to this component. Just like this. This one how to get, because we haven't. It's simply from trigonometry basically. When we go to the example, you can try. But this one is not straight away. It's not the same way to get the x, y, z component, right? So we'll have the equation for alpha, beta, and gamma. I assume you have seen this before also, right? Cos alpha is ax over a, cos beta is ay over a, cos gamma is az over a. So this is how to get, meaning if you want to get this value here, right? Because you want to express in terms of Cartesian vector form. So what is ax is, basically you just rearrange that, it will become a cos alpha, ay is a cos beta, az is a cos gamma. Right. So that is when you have this angle given. Okay. Any question there? So that's two ways of the angle can be given. Of course, this is from mathematical. You have seen this before also, right? Cos alpha from plus cos square alpha plus cos square beta plus cos square gamma is equal to 1. So it is assumed that you have already memorized this one. This become important when sometimes the question only gives two of the triangle. Right? For example, it just gives something like this, right? So if this is not given, you already have beta and gamma, so you can calculate alpha from this equation before applying this one, for example. Right? So yeah, because this is basically from mathematics. Of course, this is also mathematics that we just apply. Also, if you notice the how to say, unit vector, meaning from this to how to say, okay, from here, meaning unit vector again is what, if unit vector of A is basically vector A divided by magnitude of A. So if this vector you divide by magnitude of A, basically you will get, in this case, ax over a, right? And then ay over a j plus az over a. Okay, and if you notice, to relate to this equation, this is basically that X component, Y component, and Z component, right? So then you can just, because AX over A is basically cos alpha, AY over A is cos beta, Z over A is cos gamma. So it can be expressed as that also. Right. So basically this one it's just applying what you have the equation before and it becomes like that. So you don't need to memorize this one. This is just a normal process when you have already calculated before. If you want to find QA, you just divide the vector with the magnitude. But it is related in that sense. Right, so unit vector, it actually express the vector actually express the direction, because unit vector by definition, we have the magnitude is 1, right? So it's the same as alpha, beta, gamma, also describing the direction also, right? So obviously it is interrelated. Okay, addition of Cartesian vector. So if you have understood the concept before, it's the same here, right? So when you have the in terms of Cartesian vector form, X component, Y component, Z component. So if you want to add different or multiple vector, you just add each of the components, you get the resultant vector, right? So for example, if you have this vector and this vector, you want to add. So simply just you add the X component I, add the Y component J, add the Z component A, etc. Right? So it is minus. So this concept, the concept is exactly the same as before. Right? The difference is just you have 3 components instead of 2. Important notes. So this we have mentioned already. The 3D vector can be given in terms of magnitude and coordinate direction angle, or magnitude and projection angle. Now, coordinate direction angle is basically this type of drawing or this type of information, right? While projection angle is alpha, beta, and gamma. So make sure you also know the term, because sometimes the question asks find the projection angle. So you have to understand. Oh, I need to find alpha, beta, and gamma. So you need to know how to deal with both, right? To get Cartesian vector form. Cartesian vector, when you say Cartesian vector form, is basically like this, IJK. That's basically Cartesian vector form. That's also a term that you should be familiar with, because sometimes the question say express the answer in magnitude or express the answer in Cartesian vector form. Alright. And normally in the exam, the question will actually combine the two, right? Because when you have, for example, you have to add 3 vectors, so one vector will be drawn like this, one vector will be drawn like that, etc. Right? So you have to know all. Okay, this is an example. We have how many force? 2 force, right? 2 force, F1 and F2 is applied to the hook, so you have hook there. You have F1 here and F2 here. Find the resultant force in Cartesian vector form. Okay, do you know what to do? What will be the first thing that you do? First, we understand the question. Okay, when we say, because we have, if you still remember from the first chapter, the strategy is IDE, right? First interpret. Interpret meaning understand what is given and what the question wants. What is given should be understood, right? F1 is given, that's the angle. F2 is given, this is the angle. What the question wants? Meaning in the end, what will you give in terms of the answer based on that? Yeah, in the form. But what meaning what is the final answer? Is the resultant form, right? Basically like something like this, but in Cartesian vector form, right? Not in magnitude. So you have to understand that in first place, right? So that's understanding the question, and then plan how to get there. How to get here? you add what?
F1, F2, F3.
So if I know how to express f1 in vector form and f2 in vector form, then I can just add to get the resultant, right? And then that will be the answer. Okay. If the question asks for the magnitude, then you have to further calculate in square root of whatever mentioned before, right? If the question say express the say magnitude and angle, then the final answer not here. That's for the step. So those are the first thing that you need to be able to think in your head, right? Okay. So in this case, as long as you can express this one, it's okay. So F1, is there any problem to express that? What is the x component? For F1. This should be 5 seconds.
100.
100, and then the difference? Can you do you understand where the force line is? When it's drawn like that? What is 0? Do you understand why is it 0 and? Yeah, because if you imagine the axis is like, for example, x, y, and z, right? So it is in this plane, right? Which doesn't have any x component, right? It's on the plane of y and z, right? It doesn't have anything going out of the plane, right? Because when you draw like this, meaning that it's the same line, it's on this axis, right? Meaning this axis is on that, right? So it doesn't have this component. What about y component? Learn how to use the triangle. 4 over 5, right? G. And then plus 500. 3 over 5. Okay. Okay, make sure you know how to get this. Any problem here? Good. Where's the problem? Any problem?
No.
Okay. Okay, what F2? This one should be straightforward, but it seems like it's not for many of you. So make sure you polish on your trigonometry. I mentioned before, it's up to you how to polish on this basic thing, because this is the first step in a long calculation, as you mentioned before, normally in the exam. If you don't get this correct, then you just waste your time with the rest of the calculation, right? What about F2?
800 cos.
Cos? Cos. Cos 45. Agree? Cos 30. Lagi? Ada lagi? Tadi kan yang maksudkan? Okay, how many of you can get this one? Normally, for some students who never do deal with this one, it might not seem so obvious, right? Can you get this one? No, so. This one? Boleh ni? Okay, nak drop. course. Alright, so this is basically among the things that you should be able to do at the fingertip, right? Now, for those who never deal with 3D before, I'm not sure how many of you is in this case, you might need to do step by step, right? So if you can observe this lighter blue triangle there, if you look from the perpendicular, it will be something like this. Something like this, right? Can you imagine looking from the perpendicular side? So basically, this is the 800, right? Basically, this is 800. Is that right? Basically, understand?
Yeah.
This one is the Z component, right? So this is basically F to Z. Z component downward. This one is basically this line here, right? Correct? Let's label it F prime. Okay? So from here, and what is the angle? This is 45 degrees, right? Can you express this in this from this trigonometry? F to Z equal to? And that? Sine 45 degrees, right? So straight away this one. Obviously it's negative because it's going down. What about F prime? 800 cos 45 degrees. Any question here until this part? Anything not clear? This should be straightforward, unless you cannot imagine this triangle from there, right? Now, if you look at the darker blue triangle looking from top, it will be something like something like this. Alright, can you imagine? Where this is F to X, which is this one, and then this is F to Y, which is this one, the Y component, and then you have F prime here, right? It's the same line as this one, right? This one, which is the diagonal here, right? So from here, and you have this 30 degrees, right? Just looking at this, can you express F to X equal to what? So F prime cos. No, just this one. Cos 30, right? And then this one is F prime sine 30, right? And F prime you can just plug in this thing here, right? So you get 800 cos 45 degrees, which is F prime, and then cos 30. So that's why for Fx you get 800 cos 45 cos 30. If you plug in here into F prime, you'll get 800 cos 45 degrees sine 30, which is this one, right? So for those who have done this before, after you do this several times, this becomes automatic. And you can do the two step in one, right? Because basically what you do is, if you have the axis like X, Y, and Z, the force is somewhere there, right? So if you want to get X, basically you say, okay, this is 800 cos 45, cos 30, I get X. It's 800 cos 45, sin 30, you get Y, and then 800 sin 45, you get Z. So you can straight away do these two steps in one go if you have familiar with the concept. If you just, this is the first time, then I do suggest you do step by step so that this becomes something that is something basic that you do. And straight away you can, do this step and then this step, you combine step, and this become natural over time. Right, so if you have already established this one, so for FR is simply just you add the X component, you add the Y component, and you add the Z component, you get IJK. Right? Whatever value here lah. Then because normally this is just using your calculator, right? This plus this one you get here, this plus this one you get here, this and this you get this one. Right? So in terms of calculation, I know how. I assume, or it's safe to assume that you know how to use your calculator. Right? So F1 you get that one, and F2 you get this one, this value, and then you just add the two You get FR in that Cartesian vector form. Any question? Okay, so that's how you deal with 3D addition. So again, as I remind you in the first class, is it the first class or second class? Most of the example in the slides, if you think it's easy because it's the easiest type of the question, and the exam is never this easy. But if any of the questions seems even difficult in the slide, then make sure you do your exercise, because then otherwise your exam will not be something that you can manage, right? So, and of course, what we will cover in chapter 2 and chapter 3 will be normally the first step in a long calculation. Meaning, things like this normally is not the... In the midterm, maybe you can get a question like this, because in the midterm you only cover several chapters. But when you have your final, which will give you, the weight is 50% of your mark. Things like this is the first step of a longer calculation. Normally it's only 1/5 of the length, right? So if you struggle here, then how to say? Make sure you do not struggle in these things, because otherwise it's just easier to drop and take a break next semester. Because otherwise the rest of the concept that we learn, this will be always the first step of the calculation also, right? So make sure you are not left behind in chapter 2, chapter 3 especially. And it's not only the concept, because this thing, when we discuss the concept, it's easy to understand. The issue is whether you have enough exercise so that the steps, you can go through the steps in the minimum time. That's the thing. Minimum time and also no mistakes, right? Okay, this is some basic just concept quiz, right? If you know only UA, the unit vector of A, you can determine which one of the vector A uniquely. Is it magnitude, angle, alpha, beta, gamma, component AX, AY, Z, or all of the above? This is just to see whether you grab the concept that we have covered. Any of you can answer? Or in other words, can if I ask, okay, do you understand the question? If you only know the unit vector of A, what part of vector A can you determine? Can you determine the magnitude? No, not the magnitude of UA, the magnitude of A. Can you determine the magnitude of A? If you know only UA. No, right? Because it doesn't have any information about A, right? It doesn't only have the information of the direction. Can you determine alpha, beta, gamma?
No.
Can you determine AX and YZ? From UA? Is it? How do you determine? Okay. This is okay. Question like this normally is just to see whether you understand the concept. And based on the response of the student mainly, I think you should be glad that the question like this normally do not appear in the exam. I'm not sure. Maybe because it takes time for the student to grab the concept. Now, if you have vector A, right? So if this is magnitude, this is the vector, right? And then you have magnitude 1, this one, right? So the question says, if you only know this one, this is the only thing that you know, what can you know, right? So can you know the magnitude of this one? You don't have any information, right? Can you know AX, AY, Z?
No.
Which is the X component, Y component of this one? You don't have any information also, right? Actually, you can determine alpha, beta, gamma, because this one describes the angle. Alpha, beta, gamma is also the angle, right? And if you recall, one of the equation is UA is cos alpha right? So it's directly related. So if I know, when we say you know UA, meaning you know X, Y, Z, I mean the Cartesian vector. So you actually can calculate alpha, beta, and gamma, right? So that's the only information. So the concept behind this is basically unit vector only gives you information about the direction or the angle. It doesn't give you any information about the actual magnitude. Okay, we'll skip this one. Now, let's try this one. Let's see if you can deal with this, right? Here the difference is you also have alpha, beta, and gamma. So the question is, we have basically still two force, F1 and F2. F1 and F2, you have the angle given. Find the magnitude and the coordinate direction angle of the resultant force. Okay, first question, do you understand the question? Of course, what is given is still the same, F1 and F2, the direction. What is it that the question wants in the end?
Resultant force, direction.
So, because in the previous question, it only wants you to give you the resultant in the Cartesian vector form. In this question, you have to go one step further where what is the magnitude, which is, you can calculate there. And what is coordinate direction angle? Anyone remember? It's basically alpha and gamma. Right, so make sure the question never asks find alpha, beta, gamma. They will just say find the coordinate direction angle. So you have to understand. Okay, that means I need to find alpha, beta, and gamma. Right. So make sure you understand these types of thing also in terms of the term used, so that you know exactly what the question wants. Otherwise, in the exam, if you miss what the question wants, you might lose some mark or you might go in a different direction altogether. Now, so the step will be the same. If you can express in terms of Cartesian vector form for F1 and F2, you can just add, and then for magnitude, you can just square root the component, and then alpha, beta, and gamma, you just relate the X component, Y component, Z component, right? So, try and see whether you have any problem to express F1 and F2 in Cartesian vector form. We have the example already how to deal with these two triangles here. Let's see if you can use apply for this one. Basically, if you have to, you just draw the two triangles there. Try to express F1 and F2 in Cartesian vector form first, just to check whether you are okay or not with that part. Okay, any problem for F1 and F2? Yang ni tak dapat. Okay, F2. Itu buat F1 ke F2? F1. Oh, macam nak guna dua triangle ni. For F2 any problem? Because F2 should be direct apply for alphabet number. Your triangle must be a right angle triangle, 90 degrees. And you will have trouble to determine where, because in this case, where is the 90 degrees? Is it here or here? Here, right?
Yeah, it's
For this triangle, where is the 90 degrees? Is it here?
views.
Is it?
No, atas.
Because if you make mistake there, you have to because the 90 degrees is here, right? And if you draw the way you draw from the axis, right? Because if you make 90 degrees in the wrong place, then obviously your calculation will mess up. Because in this case, this is the hypotenuse. In this case, this is the hypotenuse, right? Because this is x component, y component, right? Hypotenuse. So those are among the things that if anyone who lack practice can easily make a mistake there, because it appears to be like 90 degrees elsewhere, right? The way the drawing looks like. So anyone have different triangle and everything? Okay. So how many minutes already here? Because the time that, especially in the exam, the time allocation should be, you can just look and you should be able to express. For example, for F1, 250 cos 35 and sin 35, right? Correct. Positive, and then plus 250 cos 35 cos 35 t minus 250 sin. That is if you do in one go. Right. And it should be the same. For f1z is 250 sine 35, it's the same. For fx is 250 cos 35 and then sine 35. Yeah, and then 250 cos 35 and then cos 25, that's it. Do you get that? Anyone get different? Or if you do not get, where is the issue? Where is the problem? Make sure you understand, identify where you have the problem and resolve that one. That's all. Any question? Okay, is it okay? Yep.
So for that triangle with 25 degree, how come the 90 degree at that part, not at between f1x and f prime?
Okay, if you okay, this one, okay, first do you understand that this line here is in the xy plane? Meaning that if you have xy, it's somewhere here, right?
Yes.
So normally, and if you, so in xy plane, right? And you say that xy plane, right? So somewhere here. When you make a triangle, obviously this is the, or this one is the right. Meaning it have the x component and y component, right? So because this one is in the xy plane, so it will have the xy component. Any other question? For F2, anyone have solved? What is the x component of F for F2? How do you get 0? What is given in F2? You have this angle, and this angle, right? What are this angle? This is F2, right? What is this angle? This angle and this angle?
What is it?
Oh, you cannot detect. It is already given in terms of alpha, beta, and gamma, right? You tak tahu. What is this? Okay. Do you understand what is alpha, beta, and gamma? What is it? What do you mean by x, y, z? Is angle between what and what? Yes. Angle between x and y is 90 degrees. You mean x axis and y axis? X and z is also 90 degrees.
Alpha is the angle between the z and the plane.
The plane lah. So if you have x axis, y axis, and z axis, right? If you have everything here, so the angle it makes with positive axis is alpha, right? The angle it makes with the positive y axis is beta. The angle it makes between with the z axis is gamma. So that's by definition. So if you look here, it gives exactly that. This is to the x axis positive, positive y axis, and positive z axis. So if you already are given in terms of alpha, beta, and gamma, how do you get the vector? What is the x component then? So you have 400. This should be like less than 1 minute. Cos 120 plus 400 cos
45.
45t plus 200 cos 60. So that is how you get if you are given alpha, beta, and gamma. Right. Obviously, for I here it will be a negative value, right? When you cos 120 because it's the second quadrant, you get negative. So if you use alpha, beta, and gamma, positive and negative will automatically come up with this value. Do not put negative here, then it will be redundant and it will become wrong. Because as you can see, the x component is going in the negative direction, right? But you don't put negative here because alpha, beta, gamma is already cater for the positive and negative. But for this type of calculation, the negative and positive you have to understand from going which direction, right? Here negative you manually put. So that's the difference between the two type of direction given, right? Okay, so if you already get that one, so F1 you should get this value here if you calculate that one, and F2 is simply cos alpha, cos beta, and cos gamma. You get this value here. So if you already get F1 and F2, FR is simply just you add the component. From here, how to get to the magnitude? You're going to get F magnitude, FR, how do you get from this value? You can get the answer, right? What about alpha, beta, and gamma? Got the question, if you still remember. The question alpha magnitude and alpha, beta, and gamma. How do you get alpha? Cos? What you put here? Do you remember the? So you get the x component, right? Minus 113.4 divided by A, which is mana? The value here lah, right? Which is the magnitude there, right? So here is cos -1 or 68.4 divided by this value here. Make sure you take also the negative notation here because it will affect the angle, right? When you have negative, it become more than 90 degrees. So if you calculate that one, you will get this answer here. Because when you get the magnitude is 44.85. So alpha is simply just cos -1, this one over 485. You get more than 90 degrees obviously, then you get this value. Any question? Okay, so I think, any question? I think the concept should be straightforward. Just that if you are not familiar on using how to calculate alpha, beta, and gamma, or even determining what is the Cartesian vector for each force, then you desperately need a bit of exercises so that that becomes something natural to you. Okay, so as we mentioned, because I have reminded in the first class, unfortunately we do not have the tutorial class, when normally the tutorial will at least give you some bit of exercises. So you have to be independent in terms of finding your own time to do some exercises, right? Otherwise, you cannot blame anyone else when with whatever you get for your exam. Okay, attention quiz. This is basically just to see whether you are paying attention. What is not true about unit vector UA? Is it dimensionless? It's not dimensionless? It is dimensionless, right? Is the magnitude F1?
Yes.
Is it always in pointing in the axis?
No.
No, right? It points to the. So this one. The one that point in the x-axis is I, right? Okay, if F is 10I plus 10G plus 10K and G is 20I plus 20J plus 20K, F plus G equal to
B. C, D.
Okay, so you add, you get that one. So, okay, we have finished this part. So meaning we have completed roughly half of chapter 2, I think. So we have some more to go. We already are behind schedule a bit because of the holiday that we have, right? Okay. So we go into position vector, right? So hopefully you try to keep up with what we are covering, right? Now there are several things that we. So if you have any question, please make sure you understand all of this, because as I mentioned, whatever we cover here is the fundamental or the basic tools to calculate for the longer calculation in later chapter. Right? Basically, we are dealing with position vector and force vector, right? So because in the question we are already dealing with force, but in reality, because here we get the, if you notice, we get the vector force from a force and the angle, right? But in reality, normally the force itself is not known. What we can measure is the distance. So how to deal with that? So we go a step further into this concept here. Alright, so example is like this, right? If you want to find what is the force here, right? Because if you notice here, how to get this value here is from a known force, right? And an angle, then we calculate this one, right? But normally the force that we want to calculate, the force is actually the end of the calculation normally, because what you can measure is we can measure the distance. The force have to be calculated. So the calculation direction is a bit opposite in that way, right? So similarly here. Okay, what is position vector? Position vector is a vector that locates a point in space relative to another point. So in other words, is basically express what is the vector that connects two points. Right, so that's basically it. So if you have point A and point B, so position vector denotes as R. AB is basically a vector that express what is it? The vector from point A to point B. Right? If you go the other way around, normally we'll express it as BA. Right? It's not the same because the direction is opposite. So that's basically it. Meaning the concept is just to relate 2 points in space. So if you have the coordinate, like say this one is AX, AY, AZ coordinate, no, that becomes a vector. So XA, YA, ZA, right? Because it's XYZ coordinate here, XYZ here, X, B, Y, B, Z. The how to calculate this RAB basically is just basically the end point or the destination minus the starting point. Right? Have you covered this before?
Yes.
Yes. And so let's see the XB minus XA I plus YB minus YA J plus ZB minus ZA K. Right? And then you get the vector. So I believe this is nothing new to you, right? So we'll get the coordinate. Always subtract the tail coordinate from the tip coordinate, right? So in some question it will already give you the coordinate. In some question you actually need to determine what is the coordinate from whatever else information given. Right? So make sure you know that also. Okay, force the vector directed along a line. So the idea is this: if we have a line and then we have a force along this line, right? If we know the unit vector, right, then vector f is simply f times unit vector, right? Understand this concept, right? And this unit vector can be determined by any vector that we know in this line divided by the magnitude. Right? So the easiest vector that we can get is if I know this coordinate and this coordinate. For example, this is A, this is B. Right? So if I calculate what is R, A, B, you can get the vector, right? From here, get the vector. Can I know R, A, B the magnitude? If I already get this vector?
Yes.
How?
Square root.
Let's say square root of the x, y, z component, right? If you know this one, you can determine this one straight away by R A B vector divided by R A B magnitude to get the unit vector. Once you get the unit vector, you can just multiply with the magnitude of f to get the vector f. Understand? So normally that's the cycle. You see whether you know the coordinate. From the coordinate, you know the position vector. From there, you get the magnitude. If you know this one, you divide, you can get the unit vector. If you know already the unit vector, you multiply by the magnitude, you get the vector. Right. So the concept is simple, but when you do the calculation, it can be a bit long, right? But it takes a bit of space to calculate each of these. And normally, when, for example, if you have F1, F2, F3, for example, right? And then the question say find the resultant. And for each F1, F2, F3, you have to repeat all of these. That is what makes the question long. Right? It's not difficult in the sense of the concept. It's just that it takes some time to do the calculation. And this is where, if you lack practice, you will take a lot of time, too much time, which makes it not how to say, you'll never finish the exam on time, right? If that is the case. So make sure you have enough practice. So basically that's the normal flow, right? You get the RAB from the coordinate, you get unit vector by dividing the position vector with the magnitude, and then you can express the force in Cartesian vector form. Any question? You follow this concept? Okay, about 10 minutes. So let's take a look at this example. Okay. So in this case, we have two forces FA and FB and FC. Of course, the question here only focus on the step, so it just focus on one of the force. So one of the force is 420 Newton, which is FC here. So if you want to express FAC in Cartesian vector form, do you have any problem here? What will you do if you want to express FAC or FC here, 420 Newton there, in vector form? According to the flow that we have mentioned before. What the first step? Coordinate, right? So you have point A and point C, right? So point A is what is the coordinate?
6 plus kosong 6.
X coordinate is
0 6 0 6.
Y coordinate?
0.
0. Is that?
6.
6. Okay. Coordinate of C? X coordinate?
As coordinate Two.
2,
Y three.
3, 0, right? Make sure you get the coordinate correct. Otherwise, your calculation will all be wrong and such a sad story. Okay, so if you already determine the coordinate, so you can calculate RAC, right?
Yes.
What will it be?
6I.
Basically this minus that one, right? So what? 2 minus 0 is 2I. 3 minus 0 is 3J. 0 minus 6 is minus 6K, right? Any problem there? So RAC is square root of 2 square plus 3 square plus 6 square. What you get? 7. So from here you can calculate unit vector UAC. Basically this divided by this. So you get 2 over 7I. So 7 kan? Saya percaya gini. Plus 3 over 7J minus 6 over 7K. If you want to be precise, then the unit here is meter, unit meter. You divide, the unit is cancelled, right? Dimension. And then you know the force is 420 Newton, right? So F is 420 times this vector here, right? And then you get what we were in terms of I, J, K, right? So is it difficult? Is it understood?
Yes.
Of course, this example just focus on how to do this one, right? Because normally the question will ask something else, where you have to find this in vector form, and then you continue your calculation. So that's why we are saying this is normally the first step of a longer calculation. So make sure you don't have any problem with any of this, and you can do it in the minimum time, inshallah. Alright, so in terms of calculation, so we have done this one. So in the end, you'll get this value here. Alright, concept quiz. P and Q are 2 points in 3D space. How are the position vector RPQ and RQP related? Which one? B, why? Direction, right? If you, for example, this minus that and that minus that is basically just the negative of each other, right? Okay, if F and R are force and position vector, meaning that if this is force, this is position vector, what will be the unit of this one? This is just to see whether you can deal with units. Is it? Huh? Sana ikut What is the unit of this one? Newton. R. What's the unit of R? Meter, right?
Yes.
This is Newton divided by Newton, so you get meter, right?
Yes.
This is just to test whether you can deal with a unit. Right? Okay, so I think this is okay. We have just enough time for this one. So group problem solving. Two forces are acting on a flagpole as shown in the figure. So FB is 560 and FC is 700 Newton. Find the magnitude and coordinate direction angle of the resultant force. Do you understand the question? FR. Yes, you want to find FR in terms of the magnitude and the alpha beta gamma, right? Before you get FR, you have to know what is both F in vector form first, right? So let's see if you have. Try for which one first? FV. Is there any problem? Look, get for FB. Okay, what do you do? Coordinate, right? So you have from A to B. Right? A is coordinate
0, 0, 6.
0.006 B.
Is
Huh?
two.
2.
0.
Is it? -3. Right? So make sure you pay attention now to the positive and negative. So RAB will be this one minus this one, right? So 2 minus 0 is 2i minus 3j minus 6k. RAB, you guys calculate, you get 7, right? That's the same number as before, right? UAB, of course in the exam you cannot write like this. You have to actually write proper. So you have 2 over 7i minus 3 over 7j minus 6 over 7k. So F, this is F, A, B. What is this F again? F, B is 560. So you have 560 times 7i minus 3 over 7j minus 6 over 7k. You can straight away calculate. What about FC or FAC? So A to C, right? So A is 0.006, C is 3, 2, 0. So RAC is 3i plus 2j minus 6k. IC 7, Q is C, 3 over 7i plus 2 over 7j minus 6 over 7k. FAC is 700, 3 over 7i plus 2 over 7j minus 6 over 7k. This can straight away. So after you get these two,
Plus.
FR is simply FA. This one is FAB plus FAC. You get into vector form. Then magnitude, you can calculate, and then alpha, beta, and gamma. You can calculate also, right? With the x component divided by this one, y component divided by this one, and cos -1, x component divided by this one, etc. Right. So that's really the calculation steps, right? Because of the time factor, I normally just focus on the steps. Hopefully you can follow the steps. The value you can verify and calculate yourself, and the slides. I think the slide is already available also, right?
Yes.
So for FAB you can get this value, for FAC you get that value. Then you can calculate the resultant, vector, the magnitude, and then alpha, beta, and gamma. Okay, so any question? So we have covered two parts today. One is how to deal with 3D with the angle, two different type of angles, and then resultant. We also have learned about position vector and how to use it to calculate unit vector and use the unit vector, right? Attention quiz. Okay, in 30 seconds. What is this? P is 1, 2, 3. Q is 4, 5, 6. RQP. Which one? Is it? Which minus which one? If RQP, which one minus which one? It's from Q to P, so P minus Q, right? So which one is the answer?
P.
So it should be negative there, right? So make sure you are aware of that. If force directed along PQ, then it can be expressed as which one? Which one will be equivalent to F? And you detect. Why see? What is this one if you notice? This is equal to U, right?
Yes.
So you just multiply by the magnitude, you get F vector, right? Okay, that's the end of this part. So, okay, we are also out of time, so we only have one component left in chapter 2. So we'll cover that one in the next class. So most probably, because we have next class will be already in the 3rd week, right? So we have to start a quiz. So most probably in the next class we will have a quiz on the part that we have covered so far, right? So be prepared. And anyway, you really have to do some practices anyway for what we have covered. Otherwise, it will be too late when we formulate new things that we have learned. Because if you notice, most of the things that we have learned here, the concept you already have learned before, right? It's just that maybe lack of practice, etc. You have struggled. But later on, there are many even new concepts. So if this one you do not resolve as soon as possible, then it will be too much later on. So we'll end here, inshallah. See you in the next class. So Monday holiday, right? So fortunately Tuesday is not holiday. Otherwise we have too much holiday. So see you in the next Tuesday. We'll end the class here, inshallah. Subhanakallahumma wa bihamdika. Assalamualaikum warahmatullahi wabarakatuh.